You are standing outside on a clear night. You look up. You see maybe 2,000 stars with your naked eye. That feels like a lot. It is not, because what you're looking at is not the universe. It's a keyhole, a tiny, local keyhole into something almost too large to hold in your mind. Let's open that keyhole all the way. Start with something familiar. Your planet. Earth is about 12,700 kilometers wide. You could drive around its equator in a few weeks if roads existed the whole way. It feels enormous when you're standing on it. But hold that thought. Now picture the sun. If Earth were the size of marble, the sun would be the size of a large beach ball, more than 100 Earths wide. Over 1 million Earths could fit inside it. And yet the sun is an average star. Not the biggest, not the brightest, just average. Now step back further. The distance from Earth to the sun is about 150 million kilometers. Light, moving at nearly 300,000 kilometers per second, takes about 8 minutes to cross that gap. That means when you see the sun, you're seeing it as it looked 8 minutes ago. A small delay, barely noticeable, but it's your first clue, because the further out you look, the further back in time you're actually seeing. Now leave the solar system entirely. The nearest star to our sun, Proxima Centauri, is about 4.2 light years away. A light year is not measured time. It's a measured distance. Specifically, the distance light travels in 1 year, about 9.5 trillion kilometers. So when you look at Proxima Centauri, you're seeing light that left it 4.2 years ago. If it vanished tomorrow, you wouldn't know for years. That's just the next-door neighbor. Our sun is one of roughly 100 billion to 400 billion stars in the Milky Way galaxy. The galaxy itself is a flattened spiral disk about 100,000 light-years across. Light takes 100,000 years to cross it. To drive across it at highway speed would take longer than human civilization has existed, several times over. And the Milky Way is just one galaxy. This is where the astronomer Edwin Hubble changes the story. In the 1920s, using the Hooker telescope at Mount Wilson Observatory, Hubble discovered that a faint, fuzzy patch of light in the sky, what astronomers had assumed was a nearby cloud of gas, was actually an entire separate galaxy, far beyond the edge of our own. He'd found Andromeda, and with it, he proved the universe was far bigger than anyone had believed. Andromeda sits about 2.5 million light-years away. The light entering your eye tonight, if you looked at it, left Andromeda before modern humans existed. You'd be looking at ancient light arriving late, like a letter mailed 2.5 million years ago, just now reaching your mailbox. Now here's where it gets almost impossible to picture. Andromeda is not rare. It's not special. Current estimates, refined by missions like the Hubble Space Telescope and more recently the James Webb Space Telescope, suggest there are somewhere between 200 billion and 2 trillion galaxies in the observable universe, each one containing billions of its own stars. Do the math for a second. Multiply a few hundred billion galaxies by a few hundred billion stars each. The number of stars in the observable universe alone is roughly comparable to the number of grains of sand on every beach and desert on Earth combined, possibly more, and we still haven't reached the edge. The observable universe, everything whose light has had time to reach us since the beginning, is about 93 billion light-years across. Not 93 billion light-years away. Across. That number sounds like a typo because the universe itself is only about 13.8 billion years old. How can something be 93 billion light-years wide if light has only had 13.8 billion years to travel? Here's the twist. Space itself has been expanding this entire time. The astronomer Vera Rubin, studying the rotation of galaxies in the 1970s, found stars moving in ways that couldn't be explained by visible matter alone, evidence that pointed toward what we now call dark matter, an invisible scaffolding shaping the cosmos. Combined with later discoveries about the expansion of space, scientists realized that as light travels toward us, the space it's crossing keeps stretching. So the light left its source a long time ago. But by the time it reaches you, its origin point has drifted much farther away. That's why the observable universe is so much wider than its age would suggest. The universe isn't just old. It's still growing everywhere, all at once. So picture this. You're floating at the center of a sphere 93 billion light-years wide. Every star in it, every galaxy, is casting light toward you that started its journey years, centuries, or billions of years ago. None of it shows you the universe as it is right now. It shows you the universe as it was. That includes the Sun 8 minutes ago, Proxima Centauri 4 years ago, Andromeda 2.5 million years ago, and the most distant galaxies ever photographed, captured by the James Webb Space Telescope, showing light that left its source over 13 billion years ago, from galaxies that formed when the universe itself was still in its infancy. You are not looking at the universe. You are looking at its history, layered in light, all arriving at your eyes at the exact same moment. And here's the part that should genuinely unsettle you. Beyond that 93 billion light-year sphere, there's almost certainly more universe, space that we will never see. Not because it isn't there, but because its light hasn't had time to reach us yet, and because space is expanding faster than that light can close the distance. There could be galaxies, stars, entire structures, permanently beyond the reach of any telescope humans will ever build. So when you calculate how big the universe is, you're not actually measuring the universe. You're measuring the size of the piece we're allowed to see. Now bring it back down to you, standing outside, looking up. 2,000 visible points of light in a universe that may contain 2 trillion galaxies. You are seeing a fraction of what exists, and even that fraction is ancient light, arriving late, from places that may no longer look the way you're seeing them now. Carl Sagan once described Earth as visible in a photograph taken by Voyager 1 as a single pale blue suspended in a sunbeam nearly 6 billion kilometers away. That image, and Sagan's reflection on it, was a reminder that everything you have ever known, every person, every event, every home, exists on that one tiny point of light. Now scale that same feeling upward. If Earth is a pale blue against the sun is a barely visible speck against the Milky Way, and the Milky Way itself is one faint smudge among hundreds of billions, possibly trillions, of others. You are small, not in a way that should make you feel insignificant, but in a way that should recalibrate what big even means. Every worry, every deadline, every argument you've had this week is happening on a speck, orbiting a speck, inside a galaxy that is itself a speck, inside a universe so vast that most of it will remain forever invisible to you. So the next time you're standing outside on a clear night, looking up at what feels like a sky full of stars, remember what you're actually seeing. 2,000 points of ancient light. A keyhole, not the universe. Just the smallest possible glimpse of it, arriving late, from a past that no longer exists, inside a universe that is still, right now, quietly getting bigger.